Alright, to make this one easier to do, differentiating log of all that stuff, we could always let u equal to the inside, and then I could do du dx, so differentiate u with respect to x, use the chain rule, so that's minus a half, and we're timesing by 2x. So you can see this would give you 1 plus, you've got a half times 2, so that's 1, and you end up with x over square root of x squared plus a squared. And we could also write square root of x squared plus a squared plus x over a common denominator of x squared plus a squared. And then we could also have a look at y being then log of u. So dy du would equal 1 on u. So if we wanted dy dx, then we would do dy du times du dx. Those would cancel, we get dy dx. So we have our 1 on u, u being x plus square root x squared plus a squared. That's our 1 on u, and we're multiplying it by our du dx. So we've got, I'm going to x squared plus a squared under square root plus x all over the square root of x squared plus a squared. And you can see there that this and this are exactly the same, even though I've written in a different order. So they cancel, and all I've got left is 1 on the square root of x squared plus a squared, which is what we were looking for. So that's one of the formulas, I think, in your SI table, in your reference booklet. So in the old form we used to call it the SI table, and it was in there. I'm not sure if it's in there now, just having a quick look. Anyway, so it used to be in there, maybe not anymore. So let's just show the other ones, and the same way with the other one, we can let u be the inside. In this time has a subtraction, so du dx being 1 plus, I should have put it to the power of a half, so a half x squared minus a squared to the negative a half times 2x using chain rule. So again, you can see the 2 and the half will cancel, so that we are getting an x over square root x squared minus a squared. So if I make a common denominator, that 1 will be square root x squared minus a squared. So that's du dx, and we already know dy du, so there, dy du, so log u becomes 1 on u, so dy dx would be, I'll just put dy du being 1 on u, and that u being x plus square root x squared minus a squared, and we're timesing by our du dx, which is x plus, I'm writing it the other way, x squared, minus a squared, not plus, that's a minus, all on square root x squared minus a squared. And again, we can see that these are the same, so they will cancel, and we will be left with 1 on square root x squared minus a squared. So using those, and you don't have to separate it into u equals, just makes it easier to show you. You could do it in your head if you want. So yeah, so using those, if we want to do the integral from 0 to 1 of this square root x squared plus 1 dx, oops. So think about it, if you differentiate by going that way, then you integrate by going that way. So if we're integrating something that looks exactly like that, where a equals 1, we're going to get log of x plus square root of x squared plus a squared, a being 1 is 1 squared, which is 1. That's what we're going to get, and it's a definite integral. We're going between 0 and 1. So if I sub 1 in, we get 1 plus root 1 squared plus 1 minus 0 plus square root of 1, which is 1, which is log, so this becomes log 1, which is 0, so we just get log 1 plus root 2, and that's our answer. Alright, and doing the other one, so this time we're using the other result. We have, let me just move that there, we can right on top of it. There we go, that's easier. So you can see the 16 is the a squared, so a must be 4 in this case. So if I'm integrating, I'm going this way, so it's a definite integral, so I'm saying log of x plus square root x squared minus 4 squared, and I'm going between 4 and 8. So if I have a look at that log, I'm not going to need this absolute value because it's already positive. 8 plus square root 8 8 64 minus 16 minus log, again I'm not going to need it, 4 plus square root of 4 squared is 16 minus 16, so that's just log 4 there. So here we've got log 8, bracket 8 plus, so 64 minus 16 is 84, which is 4 root 3, so that's 4 root 3. This will be minus log 4. Using log laws, that becomes log of 8 plus 4 root 3 divided by 4, which is log of 2 plus root 3. There's our answer there.